7 ways to create resilient solutions. And today we have Alan Murray as our speaker. Good morning to you, Alan.
Good morning, good evening, everybody in Sri Lanka.
Alan is the VP of Enterprise Architecture and Application Development of Cushman Wakefield, US. So once again, without any further ado, Alan, the virtual stage is over to you.
Thank you so much for the introduction. Great to be here again at Dev Day for another year. So thanks for having me back. So as it said in the intro there, the pace of digital change is ever increasing. But what I want to talk to you today is a way to temper that with some resiliency, because it's never that simple. So as mentioned, I'm Alan Murray. I am the head of application development and architecture at Cushman & Wakefield. And I've spent the last 10 years with my awesome team developing a number of systems, hundreds quite literally, of all shapes and sizes, whatever you can imagine. And not everything has always gone so smoothly. There's sometimes been some bumps in the road with what we've been have to build or overcome unforeseen obstacles. Over that time, we've become wiser about these issues that we've faced, and that's led us to build in a new way that is more resilient and more fault tolerant to make sure that these solutions we put out there stand the test of time. And today I'm going to share with you some ways that we as a collective group have come up with to make these things more resilient and make them able to withstand change and unforeseen things. But first, I'm going to take you on a little trip back in time and tell you a story about why this is not anything that's really new. If you cast your mind back to the Great Depression, this is the 1930s in the US, the US Army Air Corps introduced a contest in which they wanted to spur economic recovery in specifically the aviation industry. And they put out a challenge to all the companies in this space to build a faster, better aircraft, specifically with long-range capabilities. And amongst the companies that responded to this call was the Boeing company. On October 30th, 1935, in Wright Field, Ohio, everybody arrived to show off everything that they've done. And the US Army Air Corps was watching to see what the contenders had brought. Boeing had been developing the new M299, which would later be renamed the B-17, also known as the Flying Fortress. And it was one of the most technologically marvelous things of its age. And at the moment that they designed this, it was the newest, most fastest, long-range capable aircraft in the world. On the day, the conditions were perfect. It was a great fall day. And the 299 taxied onto the runway with a crew of 5. And at the controls was Major Ployer P. Hill piloting the aircraft. The 4 powerful engines revved up, and the aircraft gained speed as it ran down the runway, enough to lift it off the ground and start its climb into the air. But what happened next was something that seemed very wrong to the observers on the ground. Instead of leveling off, as it was supposed to do, the aircraft proceeded to keep its nose up and continued its climb, up and up, until it finally stalled. At about 300 feet, the aircraft's forward momentum arrested and it began to plummet straight towards the earth, flat on its belly. It was loaded with fuel, having just taken off, and it immediately burst into flame upon the impact. The onlookers ran in and tried to retrieve the crew, but due to how the plane landed, 3 out of the 5 crew survived. After the incident, the US Army Air Corps began an investigation into the crash, and there was a lot of initial speculation as to what caused the plane not to level out. Was it the autopilot that was jamming the controls and preventing the pilot from overcoming that? Was it human error? Was there a fault in the controls? After all, this was a new aircraft. After much searching, they happened upon the real cause. One of the newest features of this aircraft was a control locking mechanism that would lock the elevators in the correct position while parked on the ground. And if you don't know what elevators are, they control the pitch of the aircraft, which is the direction or the angle of the nose on the plane. In most aircraft up at this time, this mechanism was on the outside of the plane, and it was disengaged by the ground crew before the plane took off. In the M299, though, as part of a new feature, this control had been moved inside the cabin of the plane, and the crew had forgotten to take that lock off before taking off and doing their pre-flight checks. This meant that the control surfaces were locked in place, and the pilot and the crew could not overcome the stall. They couldn't have time to figure out what the problem was, and therefore the plane crashed. The additional complexity that was brought into the features of the aircraft put more burden on the pilot and the crew, and it ultimately led to the loss of life. After identifying that cause, though, the Air Force wanted to know, how can we stop this from happening in the future? And they began looking to a solution to the problem. What could have been different? Well, first off, they said, well, training. We could have more training for the pilots, make them more familiar with the plane, so familiar that they cannot make a mistake. But in this example, the pilots were extremely well trained. These were the Army's test pilots, and they'd spent months working with the plane, very, very experienced with how it worked. You could argue that more safety measures are needed, but in this case, it was a safety measure that actually caused the problem. You could argue that more testing would have been better. Again, extensively, it was tested before the crash. This wasn't a rushed procedure. And finally, you could argue, well, maybe the plane should have been better engineered. The plane was a technical marvel, though, as we said, and it was the most sophisticated control mechanism that had ever been made up until that point. What they finally arrived at was not something that was a new idea, though. It was something very old. It was the humble checklist. It was a checklist designed to go over the basic tasks during pre-flight checks, taxiing, takeoff, and landing, as a reminder to the pilots of the simple things that have to be achieved. The reason that the military leaders arrived at this was fundamentally linked to human psychology. The pilots in this case were not messing up because they were incompetent. They were messing up because they were very, very good. And perhaps this came with a level of arrogance. They weren't slowing down to go over the basics, like unlocking the elevators before takeoff. When we look at checklists, they're still in use today, and pre-flight checks are performed all the time for both military and commercial flights. But these days, the checklists are just simply not enough. When we look at the change in the aircraft cockpit designs over time, we can see some massive changes. 50, 60 years ago, the pilot was the special sauce that kept the plane in the air, and the cockpits were relatively simple devices, as you can see on the left here. If you fast forward to the modern cockpit, the image is a very different one. We have new technologies, we have more monitoring, we have more pilot aids, etc. We have bigger, faster, and more complex airplanes. And in essence, there's more things to do, there's more things to check, and there's more things to go wrong. What didn't change, though? The users. The pilots are still human beings. And human beings mean that they will still continue to make mistakes, no matter how much training can eliminate any of those mistakes. And so instead, the cockpits had to be designed for fault tolerance. The goal of the modern cockpit is not to assume that pilots are perfect and will never make a mistake, but in fact that they will make mistakes, and instead, the system will be resilient to it. So why are we talking about aircraft and cockpits and checklists? Well, what does this mean to a solution developer or a software architect? It actually has a lot of similarity. Complexity for first thing. Just like the planes, which have evolved technically, so have our applications and our solutions. They're becoming more complex and more feature-rich all the time. We also have mistakes. We have to assume that the users of our solutions will make mistakes and prepare our systems to deal with that. Remember, the goal is to minimize the impact of the mistakes and make them resilient within the system and not have the system crash when something has gone wrong. We also have training. We train our users. We spend an inordinate amount of time on training. We can emphasize the need for this, but likely users won't think about everything that they learn in these trainings. Resilience is key. So just like an application, just like a plane taking off, deploying an application has some basic steps, and if you miss them, things can be catastrophic. And when building planes, when building solutions or applications, think about the process, the flowcharts, and the ways that users will use the system. And we should always consider the negative, not just the happy path, the yes path, all the positive lines in the flowchart. We should also consider what happens when they don't do that, or choose not to do that, or forget to do that. Put simply, building and practicing your craft with fault tolerance in mind and planning for the worst using checklists and other systematic mechanisms that I'm going to show you will avoid the most common and often the most simple mistakes. So let's talk about fault tolerance. I've said it a couple of times here. Fault tolerance is just essentially planning for mistakes. So rather than taking an attitude that your system can never go wrong, will not go wrong, or perhaps only focusing on those positive outcomes, it's thinking about what happens when it doesn't go right. It's important to make our solutions fault tolerant because doing so makes them resilient. We can anticipate things that will go wrong. And when you design with this in mind from the very beginning, you can ensure that when things do fail, because they will, they do so gracefully. And the user experience of that failure is as positive as it can possibly be, where even more possible, your system can heal itself and bounce back from the critical failure. So I'm going to walk you through 7 areas to consider when we're building things that are resilient on fault tolerance. Our first area is bad data. Most every system in existence is requiring some sort of data to complete its primary function. Oftentimes, those systems are only built to handle the data that is expected, and that can lead to problems when the system's provided something unexpected or missing. The first way to deal with this is through simply form validation. It's an easy way to prevent bad data from entering your system by having the appropriate validation on your form inputs. If your system expects something to be required, match a certain pattern, for example, then ensure that that is happening by enforcing the rules on the input forms. Beyond the forms, also think about programmatic interface, such as APIs. They should also handle these similar validations. Sticking with the forms for a second, appropriate control types is another easy way to make sure that you're fault tolerant. If your system expects a number, make sure that the user is filling out a number-based field. If you expect an email address or a phone number, make sure that those types of inputs are used as well. And not only does this ensure that your system is getting the right data, but with the modern browsers and modern devices, when you use the appropriate input types, your system, your operating system usually, will provide the user with an appropriate keyboard. When they tap into a number field, a numerical pad shows. When they're in an email input field, they'll see email-related keys. The next one is strong typing. And if you don't know what strong typing is essentially not allowing for any kind of variables to be used in your system. This is especially prevalent in TypeScript, for example, and other strongly typed programming languages where you have to define the appropriate types for your data model at design time. And this is a great way to make sure that no incorrect data or bad types of data will be introduced to your system. You can also leverage linters with strong typing, and that will allow you at, again, design or development time to find areas of your application that could allow bad data into the system without you realizing it. If you've decreed that this will be a string, it'll look for a string. If you've said that this will be a number, it will prevent you putting in anything other than a number. The last area in this one is what I like to call sensible defaults, and this is probably my favorite in this section. If this, in the spirit of fault tolerance, this encourages you to think through how your user will behave and then anticipate things that they will do. If you can provide your user with the most appropriate default value rather than a blank or an undefined value, you can cut down on the bad data without a lot of additional headaches. This is also another great area for UX to shine through because your system now is responsive to your user, it's presenting them with appropriate values, and your user experience is much more satisfactory. Our next area is security exposure. And security should always be at the forefront of solution development, especially in this day and age. Every day, breaches in security cost companies both monetarily and in the reputation as well. And as a good solution architect or a developer, taking the security faults into account are also a key part of your job. We can do this relatively simply. Input sanitization, for example. This might seem really obvious, but in many cases, the input values from forms that are provided by users or even programmatically through APIs are not sanitized before being pushed into the database or executed by the application logic. And this can obviously cause a number of problems for malicious code, executing on your database, executing on your server. The next area is security scanning. If you're not a security expert, you can still get into this. There are several off-the-shelf, easy-to-use examples for doing this. They can scan your source code, they can scan your final solution, and they'll look for vulnerabilities. In particular, one that we've used in the past scans our pipelines as we deploy applications for open source dependencies that might have a vulnerability that we weren't aware of. And it'll halt the pipeline, allow us to fix it, and then retry the deployment. This all should be a multi-layered approach, though. It should be a top to bottom concern for security. Your application might have a vulnerability, but that's not where it ends. You have to also ensure that the layers of your stack, from the web server configuration to third-party dependencies to your infrastructure, it all needs to be a united front to protect your solution, protect your users, protect your data and your company. This whole environment should take a zero trust posture. In essence, everything you should do should be as most restrictive as you possibly can be. Start 100% blocked and then start to roll back little bits of functionality so that your application can function, speak to other applications, and give the users what they need. It might seem very heavy-handed, but if you're starting from a secure position, it's less likely, like the pilots, that you'll overlook something before you deploy. Our third area, again tying back to our story from the beginning, is about human error. Remember that your users are human and they will make mistakes when using your system. Your job is to make sure that the system can handle those mistakes and recover from it. And we talked about this earlier, build for the negative path. When you're designing how your user will flow through your application, make sure that you account for those negative paths. And if you're doing this with a flowchart, always question any action box or any decision diamond on that flowchart and answer the question, what if they didn't do this or couldn't do this? Maybe there's a case where the system is in a state where they cannot complete an action that you intend. This will help you build the application with this negative path in mind, and you'll avoid falling into a trap where all you see and all you build for is the happy path or the golden path, where everything is built for the perfect scenario. This is another one that bugs me a lot in many, many systems, and it's an easy one to fix. Provide the user with helpful error messages. Don't just tell them that something went wrong. Tell them what went wrong, and if you can, help them to recover from it. Sometimes they can make a mistake and you can minimize the damage to the user experience by just simply providing them with a good human readable message. And this could be as simple as explaining what just happened in plain language, and even better, how they can fix this or prevent this from happening the next time around. It builds that better user experience, but it also trains and conditions your users to not make that mistake twice, because now they know what they did wrong and now they know how to fix it. Throughout this, you should also be looking to measure your user behavior. You can do this through monitoring and analytics built into your application, and you can measure how users are behaving, where they're struggling with your code or your app, and subsequently you can adjust your product to correct it or adjust for these behaviors as well. If a large cohort of your users struggle with a particular form, for example, that should be an indicator that the form is ripe for some revisions or refactoring to help stop these errors from happening in the future. It's very easy to blame the user, but it's often not the right place to point the finger. Lastly, in this section, fail gracefully. And what that means is, even with the countermeasures that we've talked about put in place, your users can and will still find a way to make a mistake. And the most important thing to do for your system is to fail gracefully. And that means that the system shouldn't halt, it shouldn't crash, it shouldn't abruptly stop, it shouldn't leave the user in a state that is unfamiliar to them, but instead it should handle that error state and then try to help the user through the problem. And if the system just cannot find a systematic way to recover itself, then it should land the user in a state where things can be recovered later, and perhaps with a little bit of intervention. Our next area is talking about development constraints. We've all been there. There's tight deadlines, there's budget ceilings, and this can cause sometimes to take shortcuts in the solution in order to meet these demands. These shortcuts, though, can also lead to a solution that is much more error prone. And if you're given more time, more money, we might have found a way around this, but that wasn't the situation. There's some ways you can help this technical debt, though, stop creeping into your system. The first off is to use flexible architectures. This is something that we as a team have done over the last 10 years. We have revised and reevaluated our application architecture about every other year. And this has often been out of necessity to this very topic. We're constantly asked to do more with less. And so we've defined flexible architectures. We've defined and adopted positions about our architecture that allow us to build quicker, be more nimble when we need to make a change, do more with less, and extend and grow our solutions over time. We've adopted, for example, a position of cloud first and as native to cloud as we can get using serverless patterns over a traditional IaaS structure that is a little more brittle. And also we've adopted a posture where we won't do clustering, for example, because we prefer those serverless patterns. We've made some policy decisions, for example, as well, to try to steer clear of native mobile apps if we can. Investing in a native shop is very, very expensive. We have to consider different OS versions. We have to consider different devices, of which there's more and more all the time. And instead, we made a policy that we would go for a responsive design pattern instead and use one source code, one application delivered to multiple platforms. Our front-end code as well has been standardized on Angular. And that means that we can scale now, and we have a UI language, a visual design language, or style guide, if you will, on how we build our interfaces. And because of that, we can speed our time to market, and we can reduce our errors because we're doing things with a common framework every single time. The other thing that can help you when you're constrained is linting and testing as well. You can move fast, and you can cut corners, and that can lead to sloppy code. There's two great ways in this that you can combat that. One is linting, and that is a very simple but effective way to stop errors due to development constraints or just simple oversight and moving too fast. Good QA coupled with linting can also then write automated testing and help you catch errors in your source and take the time back that normally would be spent on remediating those errors later on due to poor quality code. You can also do integration testing automated through pipelines so that the product can move quicker and you can do more testing faster than you could if you were going to do it manually. Another area is peer code reviews. So we've implemented a pull review, We've implemented a pull system for our code. You can also use pair programming. This is a great way to help speed development along while catching bugs before they become in the system. We also use our pull reviews to catch issues before they're committed into the main trunk branches of our code. And mentorship can also help here as well. So the senior developers or the architects can help mentor the junior developers because they've been there. They've lived it. They've lived through these same constraints before, and they can offer some lessons learned and some pieces of advice to those that are a little more junior. And the last area in this section is just simply keep your design simple. Fundamentally, the more complicated the machine, the more likely you're going to have a failure or an error. And when you're dealing with constraints, this helps. Striving for the most simple mechanism you can get will ultimately decrease that profile that your solution has for these errors to creep in. It also reduces the support and operations load of the system and also improves the usability for your users at the same time. Number 5, consider your environment. And I'm not speaking of the broader world environment here, although we should do that too. But developers can only control so much of the environment in which their solution runs. We depend on other teams, other areas, other systems to bring our applications and our solutions to life and then keep it sustained throughout. Keep an eye on the environment that your solution exists in because it's just as important as monitoring your own application. You can start by monitoring your dependencies. These dependencies could be extremely obvious. The server that your solution runs on, for example, could be low on disk, could be low on RAM. Your database could be locking, for example. Very, very easy to monitor for those things. But some things are not as obvious. For example, the domain controller that's necessary for the authentication to your application could be offline, accidentally been decommissioned, or the cloud service that you're hosting your application on could be experiencing an outage. Some level of monitoring for the environment is key, but it should be automated and you should have alerting wherever possible. Monitoring may be more manual in certain cases. For example, paying attention to the change request board for dependencies in your structure. And when somebody brings something to the CAB board for a change, you can be ready for that planned outage. Similar to our last section where we talked about keeping your designs keeping your design simple, is consistent tiers of environment within your system. Sometimes because of budgetary constraints, human errors in setup. I've experienced that one personally many times. Or lack of planning can lead to the lower environments not being in sync with the production environments. And by that, I don't mean in a data sense, but in a configuration and a structural sense. This can make diagnostic extremely difficult, and it can lead to the attitude of "it worked in dev" types of answers when somebody says, "Why did this go wrong? Why did we experience this outage?" Wherever possible, try to make your environments as synchronous as you can, or at least make them a model of the higher environments if you're constrained by financial concerns and you can't have a fully hot replicated environment for your dev environment. Cloud infrastructure in particular makes it easier to do this. You can use infrastructure as code. You can make those servers and those other reliant infrastructure elements as ARM templates and ensure that the consistency is maintained across your environments. Take the human error out of that equation. Backup and testing. So I don't mean here again that your system is being backed up. It should be. That should be table stakes. But if you're able to achieve infrastructure as code, it doesn't necessarily mean that you're perfectly safe from failure. Your data cannot be replicated from a source code. Your infrastructure can. And so it's key to have backups that you're taking of your users' data, test those backups regularly to make sure that they're still viable and deployable. Do a mock restore, for example, to make sure that they still work. And then beyond that, back up your configuration as well. Consider that as important as your user data, because when that's not in sync or when it's not backed up, you could deploy your infrastructure as code back to your production environment. You can restore your data backup as well. But if your configuration experienced what's called config drift, you're out of luck because your environment wasn't as it existed before the crash or the failure. And now the data, the system will not operate as expected because of that. The big area here is all about redundancy and failover. If your solution being down would cause a business problem or a client commitment failure, then backups are not the only solution that you should invest in. Redundancy in your architecture should also be considered, as well as failover mechanisms to make sure that the solution is addressing the need for constant uptime. This might also not be because you expect outages, although we all should. That's the whole point of this conversation. This also could help you with your normal release cycle. I'll give you an example. Our global website that Cushman just deployed 2 years ago now is a very, very large implementation using all PaaS services on Azure. And it's built in a multi-redundant geo configuration where we can do what are called blue-green deployments. So when we have an update to our website, we can divert traffic to one of the nodes, deploy the code to the idle node, and then start to gently bring the traffic back, ensuring that everything is fine until we reach 100%. And then we take the other node offline, upgrade it as well, and then we bring the traffic back into perfect balance again. That way we don't have any downtime while we do our upgrades. Again, it was a planned outage, not an unplanned outage, but this way we can keep that constant uptime going. Our next area is unexpected usage. And this one happens a lot. Your original brief when you design the solution will quickly become irrelevant as the application goes into its lifespan. The business, the needs that drive the outcome that the application was built for will change over time. And this can cause potentially the use of the application to be in a different way than you were originally anticipating it. To combat this, design for extensibility. What that means is make sure that your application is ready to be used in new ways. Whether it's the data model, the infrastructure, or the UI, you should keep in mind that you should be designed to be capable of growing and changing over time. And this could be some new data concepts that weren't originally in the original system. That could require new form fields, or maybe an entirely new form that wasn't there before. How will your navigation in your solution handle that? It could be a new workflow within the solution, or new values and drop-down choices. The key thing here is to make sure that to realize that things can and will change over time, and things can be used in such a way that doesn't require a developer to make a change for routine data. For other things that do need a developer, make sure that the solution is architected to be extendable so that that change can be made quickly, efficiently, and with as minimal interruption to service as can be made. You can check this by doing a usage audit. You can monitor things like the UI for patterns in the way the users behave. You could also look at a change in the requests that users are making of your system. See the direction that your application is going in. You can then use that information to inform your product backlog for the future, and you should also use it to try to anticipate major architecture or structural changes before they become a barrier to your growth. You should also keep a regular feedback loop with your users. Talking to them on a regular basis is a great thing. This can provide an outlet for feedback about your application. It's also a great way to hear what they like, what they don't like, what they struggle with. And it's also great for strategically planning for product direction because it provides early insights to the technical team, and they can know and be advised and plan for those major changes or what may need to be changed so that the application continue to grow. Finally, keep your technical debt low. The best way to handle unexpected change is to make sure that the app is technically sound and that debt is as low as possible. This way, when there's a new or a game-changing feature requirement and it comes up, you're not stuck dealing with the baggage of the old application before you can start dealing on that new value. And this keeps your team and your product and your business very nimble. And you can easily then capitalize on new business opportunities, again, that weren't there when you originally built the application. In the very worst case of this that I've personally seen, we've had technical debt in some systems so large, and I'll be happy to say these were not systems that we built, but we've inherited, but they were so large that we had to scrap the application entirely and start from scratch. That's costly, that's time consuming, and it's not to mention very disruptive to your end users as well. So keep your technical debt very low, keep a growth mindset. Our seventh area is device fragmentation. The struggle is very real and getting worse with this. More and more devices with different screen resolutions, different operating systems, different browsers are arriving every single year. And when we think about browsers and OS compatibility, I personally think it's very ambitious to strive for any possible browser or any operating system version. And so what we've done at Cushman is we've actually taken a policy or a strategy where instead of doing so, we've defined a set of browsers and operating systems that will be supported. And anything that's not on that list is considered unsupported. Now, that doesn't mean that we only concentrate on the supported and we don't, we expect things to fail on the unsupported list. They may well work on those unsupported lists, but we will not spend any time as a development team investing in those things or guaranteeing it for our end users. And we make that very, very clear. As I mentioned earlier as well, we've also taken an approach of mobile-first design in what we do. And this should really be second nature by now. I mean, there's plenty of studies and articles and talks on how the growth of people using mobile devices is ever present. Many still applications, though, are still built for a desktop-first experience. And the mobile experience is simply an afterthought. It's not always enough to simply have your application go from a desktop and resort to a single column layout and be good. You have to also consider the hierarchy of the data and the components on the page and the layout that the mobile screen should respect that hierarchy to give the most important things first and hide the things that are extraneous. It could also, in many cases, be entirely possible and the right thing to build a different UI for a mobile experience than a desktop. And that's going to depend on your solution and your situation. It also keeps you honest to the design simplification principle that we talked about earlier. The thing that you should also remember is it's very easy to take a mobile-first experience and scale it up to a desktop. It is very difficult to take a desktop experience and scale it back down to a mobile experience. Accessibility. By now, we should also be considering non-traditional ways to use your solution, non-traditional browsers. They may be using a screen reader, for example, to consume your application on the web. And so it's part of your job as the solution architect or the developer to also check that your application can handle when it's being used without any of the CSS, for example. Is it still readable? Is it still hierarchically structured to make sense? Some forms of accessibility are a little bit more subtle. Color blindness, for example. If your OK button is denoted in green, and your cancel button is in red, but there's no labeling, will that be prevalent and will that make sense to somebody that sees only shades of gray on the screen? The last one in this section is to plan for slow and interrupted connections. And this is definitely true when we're speaking of a mobile experience where the coverage could be spotty, the speed of the network could be congested, and that's a big factor in the experience for your end user. This also, though, can be true for your desktop, especially with everybody working from home at the moment. I've experienced this personally where my home internet just dropped out all of a sudden. Networks can become slow or interrupted because of other things that you don't anticipate. And the sudden loss of the network can lead to the app crashing unless you have it fail gracefully. You can leverage things like web workers, service workers, to hold the data to cache it until the connection is restored, and then bring the user back into the experience. I know I said 7 areas, but I'm going to give you an 8th area, which is all around deployment. And in my opinion, this is probably the biggest one you should think about. It's easy to think about all those other areas as we're building the applications, but when it comes to deployment, it's a different animal. And we've all been there. Things are all set to launch, we've got the go decision, but the migration to production fails. So how can we overcome that, and how can we make the deployment as resilient and as fault tolerant as our application? First off, automate it. It's as simple as that. Reduce the human variables and the chance that a step can be missed. Again, remember the pilots, they missed the step of unlocking the elevator controls. This helps you automate that and make sure that no steps can be missed or the deployment won't fail. It also means that you can roll back easier because the last known good state can be retrieved from the last deployment. Obviously, it doesn't apply to the first deployment, but from that point on, your deployment is now very resilient. Even better, it puts in the checks and the guards that can halt the deployment if those conditions are not met. And that means it's not right. The environment is not right for deployment. Now, that could be the code doesn't compile. That could be that a certain number of tests are not passing. It could also be, though, considering our environment piece from earlier, that a ping to the server did not come back. So the production server was not available for the deployment to run. This helps do all those checks automatically for you. And then finally on this one, approvals. Approvals are an easy way to make sure that your deployment is even more resilient. Not because you're expecting a deployment, but in the case of unexpected deployments, accidental deployments. For example, somebody committed their code to the master branch when they didn't mean to. They meant to commit it to the development branch. The approval stage can also catch that before something that wasn't quite ready for prime time makes it into production. Source code management. This should be table stakes by now. If you're not managing your source code in a central place in a source code system, you are at a massive risk for failure. Beyond the application source code, as I spoke about earlier, infrastructure as code can also be placed into source code management, and your configurations can also be placed in there as well. Some of this can also be automated. Infrastructure as code, for example, can be deployed just like your application can, and everything therefore will be tracked and resilient. Environment variables. Anything like a token, a key, a path that needs to be changed between the lower environments and the higher environments, storing those in your pipeline as variables will help. Even better, though, if you can store them in the environment files of the solution itself, so that you're doing that at design time or development time rather than deployment. This ensures that nothing is missed. How many times have you deployed something and realized that you forgot to change a token, a key, a path, and now all of a sudden something in production is trying to point back to something in development? And when you look at it, it's fine because you have access to both environments. When your users look at it, it doesn't work because they don't have access to development. And our last one here, if you hadn't guessed by now, is a deployment checklist. In this case, think of the 5 to 10 most common things that can and will go wrong in your deployment, and then put countermeasures in place or checks in your checklist and go over them. These can be things like making sure that development and production match, that the configuration is set. Another one could be permissions. Make sure that everybody has the right permissions to do things in the higher environment that you did in the lower. It could also be checking your configuration is aligned between the environments. And finally, it could also be checking that support or other human readiness is in place to support your deployment as you go live. So things to take away from everything. Learn from the story of the M299 crew and plan for failure when you launch. You can do this with a very few small changes to planning and thinking to make sure that your solution is fault tolerant and resilient. Make sure that when you're building your applications and your solutions, you build with a mindset that allows for things to fail, and they will, without bringing the entire system down or creating poor user experience. Finally, prepare for the most common failures and use checklists to make sure that these things don't happen. Revise those checklists on a regular basis because as we go over time, new things will creep into the environment, other failures will be identified, and you should revise your checklist accordingly. Even more importantly, follow your checklist at every deployment. Thanks for listening. We'll move on to Q&A.
Thank you very much, Alan, for that great presentation. And yeah, so we will go ahead and take some time for questions now. Just a reminder, please be sure to type your questions into the Q&A section if you haven't so far. Yes, so let's give some time to sink in. Yes, we got one question, Alan, and it goes as, what type of security aspects needs to be considered when designing a resilient solution?
Yeah, so I gave a few during the presentation there, but dependency management is a very key one and a very easy one, actually. There are several things. I know Microsoft's a big sponsor of the conference, so I'll give them a plug here. But with their GitHub Enterprise that they've just released, they have a bot that if you put your source code into the GitHub Enterprise solution, it will auto scan for vulnerable dependencies. And if you're like us and you're dependent on open source things within your stack, you could easily open up a hole where you don't mean to. I also mentioned security scanning. We've invested in heavily in security scanning for our traditional infrastructure. We're also, though, evaluating and we've just purchased a new scanning solution that goes after the cloud native structure as well, because there's different types of vulnerabilities to a cloud service than there are to a traditional server, where it's more down to port opening and things like that. So there's several things you can put in place to scan for. I'm not a security expert, but I do encourage you to look into that with somebody that is more of an expert there, but there's plenty of them on the market.
Thank you, Alan. Thank you. So we have another question from one of our attendees. It goes as, how to keep a technical debt low and ongoing with ongoing releases? How and when to prioritize technical debts?
Prioritizing technical debt it should be always, simply put, but I'll give you more of an answer than this. When it comes to ongoing releases, I think the root cause of not prioritizing technical debt is not having a frank conversation with your business stakeholders, right? The people that are sponsoring this solution to exist, your users as well. And so many times over the years, we've taken a bit of a hard stance that we've said, look, we have to keep this technical debt low. That feature that you want, we can't do it because of, this technical debt exists. And what we've actually done in many cases is be a little bit sneaky. We've sometimes inflated our estimate for the new feature release. It might have been a very simple ask that they've asked us for, but we've taken that opportunity to essentially Trojan horse some paying down of technical debt when they asked us to do that. So it's taken us maybe 2 to 3 weeks versus the 1 week that it probably could have taken us, but it helps us keep the platform fresh. I also mentioned, make sure that you're revising your architecture. As I said, we do it about every other year as I look back historically, but it's actually even more in the micro than that. I mean, I would say we've significantly changed our architectures every 2 years, but as we look at our applications over time, we constantly are evaluating the technical debt. And the more you can align to that future-facing architecture, the lower your technical debt's going to be. We also at Cushman, we've invested heavily in, for example, managed services. We've actually got a bifurcated development approach where we have one team, my team, which is focused on the net new builds and defining those architectures, defining the patterns and the ways of working. And then we have another team that is solely focused on the BAU. What that lets us do is scale tremendously because now we can focus on the new and the shiny and the business value. That other team can focus on ongoing technical debt pay down, ongoing continuous improvement for these applications. But because we take that approach of revising the architecture and reevaluating the applications constantly, we never let that technical debt get too high. Again, the only real time where we've had to completely scrap an application and throw it away is when it's one that we've inherited on the back of a merger or an acquisition, and we weren't involved in the very beginning, and it's just too far gone to be able to be modernized or to be able to brought up to our current standards.
Okay, thank you, Alan. Alan, we have another question. And yes, it goes as, can you give an example for a multiplayer approach when it comes to exposing security vulnerabilities?
Yep, it's not as difficult as it sounds, I don't think. What I mean by that is, check every layer of your solution. So let's start all the way down at the infrastructure, right? Through scans from Qualys and other tools like that, you can expose any open ports. You can expose any running services that you shouldn't be running, patch levels where you might be deficient, and things like that. The next layer up would be your data layer. So run scans against your SQL database, make sure that things aren't opened up where they shouldn't be opened up, make sure that it's all restricted. Next layer up would be your solution. Actually, next layer up would be your programmatic layer, your API layer. So make sure that you're only accepting requests from valid sources using things like tokens to authenticate the caller into the solution. And again, sanitize your API, but also scan that API to make sure that if it is given something malicious, it will reject it. Next layer would be your application. So that's where things like scanning your code base for vulnerabilities with things like SonarQube or SonarCloud and other open source scanners to look for those dependencies, as I mentioned, but also code smells and poor input sanitization, as I mentioned, things like that. So when I say a multi-layer approach, I mean, don't just consider your application or don't just consider your infrastructure. Treat every layer in that stack as important as the rest of them, and make sure that you're using an appropriate scanning technology for the layer. Don't just throw all your eggs in one basket with a Qualys, for example, and expect it to work. As I mentioned, we as a company, we've invested in Qualys and other scanning tools for our InfoSec group. We were also, though, because we are moving to a much more cloud native, we are also looking at other players in the market who can do something more targeted for where we want to play.
Oh, thank you very much, Alan. Thank you very much for that insightful input on the area. Yes. So looks like we've covered all our questions from up to now. And Alan, finally, is there anything else you need to, any comment you need to add before we wrap up the session?
I will just leave you with resilient solutions stand the test of time, but they also make your life easier because you're not getting those phone calls in the middle of the night when something went bump or it fell over or something happened or you had a security breach. So it is worth investing the time in adopting this mindset from the very, very beginning as you build these solutions. And if you've already got a solution that you've built, it's not too late. Use the iterations, your sprints, your releases to start to bring it back into a line, but then adopt this mindset as a go forward.